All right, ready for the next piece on doing some more constructions in GeoGebra. And this time we're going to do some quadrilaterals. So here's a little preview of what they look like when I did them in Sketchpad, rhombus, rectangles, parallelograms. And if we do these just right, these shapes should hold all their properties once we get them built. So that's what we want to try to put together here. First one we're going to try to do is, let's see if we can do a parallelogram. So I'm going to copy a definition in like I did with the triangles. Bring it in from the clipboard. Okay, so there's our parallelogram. Not this, we're going to actually build one. So let's see. So a quadrilateral with two pairs of opposite sides parallel is a parallelogram. Now, the reason I think these are important to do is I think kids get a poor understanding of quadrilaterals and polygons in general and shapes because they build their definitions based off what they think, what they saw. Let me give you an example. Like if I drew, a rectangle. Now, technically that's not even a rectangle. I didn't define any of those to be right angles. I don't know if these are the same sides, but it looks like a rectangle, so kids go, that's a rectangle. If we draw a rectangle like this, kids go, yes, that's a rectangle. Now, I've known kids that if you did this to them, though, now let's just assume I had right angles, though, and congruent opposite sides. But if we did and we drew it like this, there are kids that get baffled. The orientation of a shape somehow is part of its definition. It just depends on how we drew it. Maybe it was elementary school, maybe it was just assumptions that the students made, but they have developed these poor understandings of what actually makes a shape a shape. So we're going to try to build these right from their definition. So I'm going to get rid of all these. So I'm going to Control Z, Control Z, Control Z, Control Z, Control Z. Okay. So we're going to build these shapes right off the definition. That way, it's true, no matter how we orient it or move it or change it or stretch it or any transformation of it, if this was defined accurately, it's going to stay a parallelogram. So let's get a segment. So I'm going to get this line tool and just get a segment. So that's going to be one side of our parallelogram. So we need 2 points to define a line. We haven't broken any mathematical rules yet. Now, to get a side parallel to this one, I'm going to need a point, just so I have a place to drop my parallel. So let's get a point, and we can put it anywhere, just out here in space right there. So we're going to sort of build it looking like our conventional parallelogram, which I hate to say because we just made the point about being precise and accurate, because we're used to seeing this squampy rectangle type parallelogram, and we all agree that's a parallelogram. But are other ways that we can make this look still a parallelogram. We'll talk about that a little bit more, but after we get this built, we can play with it and see what actually tricks up the students. So we got our one segment, and I just plopped a point out here. So let's get this line tool to do our special lines, and we need a parallel. And if you hover over it, it'll say select a point and a line. So if we want through that point and this line, there we go. Now I can't just plot another point. So this is one side, and this side will be parallel to this one. What I need now is, if this is one of my sides, I need one parallel that way. Well, since I still have my parallel line tool still active, I need a line right here actually. Let's get a segment. You know what? I'm going to get a line. So we're going to do a line from E to C. Now I need one parallel to this line through point D. Okay, I'll go back to my cursor. So no matter where I put this E, you can see that shape is two pairs of opposite parallel sides. Now let's get our last vertex right there. So let's choose from the points and the intersection tool. And I want him to look like all of his buddies. So let's change him to blue and to size 5. Okay, Now, I want to get rid of all these lines. So here's what I want to do. I'm going to get the polygon tool, and I'm just going to bounce from point to point to point to point. Okay, that looks like it'll work. So let's hide all these other lines. So get your cursor out. Now remember, if I click on it, if I hold Control and hit G, so Control G, click on this one, Control G, click on this one, Control G. Now I don't want to delete them because these points are based off of them. And then I have a segment under here. Let's see, this segment right here. And I'm going to get rid of that too. I just grabbed it right from this menu. And you can also toggle these dots on and off. But I don't want this segment underneath this because my polygon includes the sides and the vertices. So now if I move these, this should stay a parallelogram. Now this is what I was saying right before we built it. Kids, if you draw one like, let me see, like this, if you draw a parallelogram like that, most students will say, yes, that's a parallelogram. It looks like a squished rectangle. And then if you draw something like this, now is that still a parallelogram? And it's always surprising how many students to me will say, no, that's a rectangle. Well, isn't it still a parallelogram? Is it still these conditions? If so, then yes. And that's a big part of geometry, I think, is having the kids understand definition to outcome. Do these conditions hold? Then yes, this is true. And when they do work on their proofs and things like that, it's the logical step of, is this, we didn't change this condition. That still holds. Now I want to test a couple things out on parallelograms, so I'm going to grab some properties. I'm going to post this in. Okay. So this is properties of parallelogram. So opposite sides are parallel. Yes, opposite sides are congruent. Well, we know thing one's true because we built it that way. Is opposite sides congruent? Well, let's measure these. So let's get, is it this tool? Yep, there we go. And distance or length. So I'm going to click on the sides. Now the difference between distance and length, if I click on the line segment, it'll give me the length labeled by whatever the name of the line is. If you click from point to point, it'll give you distance FD. And it'll be the same. There's nothing wrong with that. I prefer to make it look like the side lengths because that's probably more like what we're dealing with geometry rather than the distance between the 2 points. But that would be the difference because it says I could do it either way. So like 2 points or a segment. That'll also grab our circumference too. But yep, opposite sides are congruent. Opposite angles are congruent. Well, let's get our angles. Okay, 1, 2, 3. And then I need 1, 2, 3. If you notice, I should be getting better at this. First couple videos, I think I clicked them in the wrong order. All right, so that works. Get this label out of the way. Oop. Okay, so yes, opposite angles are congruent, and 2 consecutive angles are supplementary. Now the diagonals, let's test that out and see if the diagonals bisect each other. So let's make it so it's not so intuitive. The more rectangle-ish, the more these angles get to a right angle, the more obvious that is. And we don't want it to be obvious just by eyeballing it. We want to actually be able to show it. So let's not make it seem too easy on ourselves because we want to do it actually precisely. So let's get the diagonals. I'm going to get a segment. I'm going to go from diagonal, and then the diagonal. And I want to measure each of these pieces. Well, let's get the intersection point, because what I'm going to do is let's do 4 segments from the center to each vertice. Because if I measure this, I'm going to be measuring the entire diagonal. I want to measure each piece. So let's get our segment tool, and we're going to do one from E to the center, F to the center, C to the center, and D to the center. Now we do have double stacked lines, and that's where this algebra tool on the side comes in a little handy. I'm going to delete those segments, and it was, I believe it was G and H. Those were the full diagonals. I just want the pieces. Oh, escape. I hit Control Z 120 times. Okay, that's better. So let's get our measuring tool and measure each segment. So there we go. That one is 735, 735, 348, 348. Grab my cursor. So now if I move this thing, do those hold? Yep. Its properties all work out. If it's a parallelogram, these are true. If I make it look like a square, that didn't make it less of a parallelogram. Okay, we beat that idea to death. So there's our parallelogram. That looks pretty good. All right, I'm going to save this, and let's open up a new one. I think we're going to do maybe four different quadrilaterals, maybe five. I don't know. Let's see. So let's save this. Okay, I just paused. I just wanted to get it saved in the right place. Because I am saving all these files that we've been doing to the Dropbox for everything. So if you had trouble with yours or you want to see mine, they're all saved in there, so you could just copy them and open them and have this exact one we just made right here. Okay, so let's get a completely new one. And I want to do a rectangle next. Now, I know we all know what a rectangle is. We probably all have varying definitions, but we're going to go with this. A rectangle is a parallelogram with one right angle. It's going to be a little bit tricky. Let's see if we can build this one right. Okay, so let's start out the same way we did with our parallelogram, and we're going to see if we can work just one right angle into this. And this should hold. So let's see. I'm going to get a line. I'm not going to do a segment. I want a full line. Because after we build it, I'm going to plop a polygon on it, and then we can hide all of our guidelines. So we're going to start with just one full line. So C to D is going to be the one side of our rectangle. Now I want one right angle. Let's build a right angle right here through C. So I'm going to choose the perpendicular line. And it wants us to pick a point and a line. So if I pick this line and that point, okay, there's my one right angle. Perpendiculars, by definition, forms a right angle. And I'm going to put a point just somewhere on this. I'm not defining the distance or anything else. We just have a point. So we know that this side creates a right angle. Now we need our parallel tool. We're going to finish it up just how we did the parallelogram. I want parallel to this line through that point. I want parallel to this line through that point. And that's it. That should be everything we did. Definition of a parallelogram was two pairs of parallel sides, and we built in one right angle. So I'm going to grab the polygon tool and map all the... Oh, I want to make that vertice first. Let's get the intersection tool. There we go. I'm used to Geometry Sketchpad, and it lets you select right on the intersection point. It might have worked on this, but I'm too nervous that if you don't click right on the point and you're clicking very close, it's not going to work. You want it right on these things that we've defined. That looks good. I want this guy to match all the others. Blue and 5. Okay, he matches, and we're going to hide these lines. So get back to your cursor, click on a line, Control G, Control G, Control G. I'm just hiding them, or technically you could come do it over here too and toggle your lines off. Okay, there it is. There's our rectangle. So no matter what and I can't move that point because that one's fixed, but this one is just defined on that line we can't see anymore. Still a rectangle, still a rectangle. All right, And here's all the properties true of a rectangle. All the properties of a parallelogram should work for our rectangle because it's a parallelogram by definition. It's a parallelogram with one right angle. So opposite sides are parallel by its definition. Opposite sides are congruent. Angles are congruent. Supplementary. And these were true right from the parallelogram. Diagonals bisect each other, and the diagonals are congruent. That's a new one. Let's measure that and test that one out. So I'm going to get a segment tool from E to D and F to C. So we have lines G and H now. Now I don't need to test the bisecting property of these diagonals again. We proved that with the parallelograms. So let's just get our measuring tool and measure H and G. Yep. And it all checks out. So even if you do this, that's still a rectangle. Still a rectangle, still a rectangle, still a rectangle, still a rectangle. Because that property holds. And I love asking students if that is still a rectangle. And it's always amazing how many of them say, oh, no, 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 it's a square now. But is it still a parallelogram with one right angle? Yes, that condition is true, and that condition is true. So if a student assumed that I just made all these side lengths equal, even if it is a square, square is still a rectangle. Because these conditions are still true. Good. All right, I'm going to, well, let's just get it back to, there we go. That's good. So we know what we've got. And I'm going to go ahead and save this. There's our rectangle. And I'm going to get a new one. All right, we're going to try doing a rhombus next. So parallelogram and rectangle. Rectangles, they're both parallelograms. Okay, a rhombus. You can guess what a rhombus is by its definition. We're going to go with this. A rhombus is a parallelogram with two adjacent sides congruent. Okay, so let's start out the same way. We're going to start out like we did with our parallelogram and rectangle. So let's grab the line tool, point, point. Now don't make them too far apart, just for convenience of having this all show up on the same screen. And got that again, Control Z. I was meaning to just move this a little bit. It's eating up a lot of our space. Okay, so we just got a line with 2 points. We'll start with that. Now the condition is, though, we need two adjacent sides congruent. I'm going to use my circle tool. So what I'm going to do is if I center it at C, click on C, and we can drag our circle all the way out to D. Now make sure you click on D. Don't just make it look like it fit. So if we click on D, now I'm going to put that third point on the circle. It really doesn't matter where. But what we just did is we defined the distance of a side length to be radius of this circle C twice. That's two of these sides. C to E and C to D are the same because they're both the radius of the circle. Now, I just need to finish making a parallelogram. So I'm going to go up here and get my parallel line tool. Now you can put a segment here. I don't want to, well, let's put a line there. I don't want to put a segment for the same reason on the rectangle, because I'm going to fill this in with a polygon and delete all these guidelines. So let's just do it with a line though. Then we can do both of our parallels at the same time. So now we can get our parallel tool. So I'm going to do parallel to this line CD through E, and parallel to CE through D. So we just made two pairs of parallel sides. That's a parallelogram, and two of these sides are congruent by how we made them. Let's put our fourth vertex with the intersect tool right there. And again, I don't like how this one looks different. So let's change it to blue and size 5. Okay, so I got my vertices. Now let's take the polygon tool And you can do this with segments, I guess, too, if you want it. I like using the polygon tool because then it shades it, it defines the area and the whole shape, and that's what we're building is a polygon anyway. So now let's turn these off. We're going to use the little toggles over here. So I'm going to turn off all 4 of my guidelines, and I don't need that circle. I need the circle. I don't want to delete it. We don't need to see it. We'll just hide the circle. Okay, so if I grab my cursor, everything should hold the way I want. Yep, it looks just dandy. All right, the properties of a rhombus. I'm going to shoot these on here. Now, I wish we could spend hours going through improving all these, but it's not part of what we're trying to do with GeoGebra, and I don't want to be typing it all up anyway, but it's a good study to go through these, and which ones of these, if true, will still make it a rhombus. So think about that. Is if any of these are true, does it always make a rhombus? If the diagonals bisect each other, is it necessarily a rhombus? Which ones make it a rhombus and which ones won't? But that's from parallelogram. Opposite sides are congruent. That was true in a parallelogram. Yes. 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 Either diagonal of a rhombus bisects a pair of opposite angles. And the diagonals are perpendicular. Let's test those out. So I'm going to get the segment tool. And let's put our diagonals. Now I'm going to put an intersection point in the center. I don't know if that's technically the center, but where these lines intersect. And let's see. So we want to know the diagonals are perpendicular. Let's get our measuring tool out and measure the angle. So if I go point, I'm doing them backwards, huh? Hit escape. I'm going to start over. Let's go F to center to E. Let's grab the angle tool and do it. F to the center to E. And like we saw before, if it is perpendicular, it'll even draw it the same way. And I'm only going to do one, because if that one's... Oh, well, that was very nice, but that's not what I was trying to do. I'm trying to grab that 90. Okay, I'm going to Control-Z a few of those back. I was trying to move the 90 so it would just be more visible. But since these are vertical angles and these are adjacent angles on a straight line, they're all going to be 90. So that's true, just like we wanted. And there's our opposite angles congruent. We can see that. They're perpendicular. We know they bisect because of parallelograms, which a rhombus is. And either diagonal bisects a pair of opposite angles. So is this line splitting this right in half? I want to test that out. So let's grab our angle measuring tool. Now we can just grab a segment and a segment and a segment and a segment. Now I am going to zoom in. Let's see if I can get some better luck. So that's the angle of the rhombus, and those are each bisected piece. Okay, I'm going to zoom back out now that I think I got it pretty good. All right, let's make this shape a little bigger. Yep, and we can see that right there. Those two bisected pieces are both the same size. So we got it. So parallel, congruent, all those are true from a parallelogram. The diagonals are perpendicular. We see that. And no matter how squishy, crazy, or whatever I do, all these properties hold because of how we built it based right on that definition. So they're always going to be at 90-degree angle. Okay. I'm going to save this one. I got one more. Let's save that and let's get a new one. And we're going to do square. And if you can guess the definition of this, similar to how we did the rectangle, we're going to define a rhombus as a square as a rhombus with one right angle. So we're going to see if we can do that rhombus construction, but with we're just building one right angle. So kind of how we did a parallelogram, it's kind of how we've done every shape up until now all at once. We're going to need the circle to keep the lengths the same like a rhombus has. And we're going to have to put in a perpendicular like we did for the rectangle. So let's get our line tool and get 2 points. And C to D is going to be one side of our square when we're done. So we want a circle around point C. So I'm going to grab my circle tool, and from C to D. Now I want my point not just anywhere on this circle. I want it perpendicular to this line. So getting the circle is what I had to do for a rhombus to make sure two adjacent sides were the same. Getting the perpendicular is what I'm going to do to get my right angle. So I'm going to get this from my special line tool, the perpendicular line. So I need to pick a line and then pick a point. And that should do it. So now if I label the intersection point, grab your intersection tool of the circle and that line, there we go. Now, again, I don't like how it's not the same. So let's get that point to size 5. Okay, so now let's finish up our parallelogram. So we've defined our right angle. We've defined a rhombus by creating two adjacent sides. And a rhombus is a parallelogram. So let's get our parallel line tool. So this line parallel to line EC at point D, and parallel to line CD at point E. And that should do it. So let's mark this intersection to get our fourth vertice of our square. Oh, hit escape. I must not have had the right tool. That's better. Okay, and I want my points to match so it looks nice. Okay, I'm going to grab the polygon tool and just fill these in all the way back to where you started, and we have our polygon. So now I can turn off all 4 of my guidelines, and the conic is the circle. I just want to hide that, and that should do it. Now, the properties of a square, it should have the properties of both a rhombus and a rectangle, because it is one of each. Since I'll cut that out. I hit Control Z. Do as I say, not as I do, right? Okay, let me get this back. What I wanted to do was grab this. I guess I have the circle tool still running. Okay, so it should have the properties. We've seen all these before. These are all the properties of rhombuses and rectangles, which are also parallelograms. So yep, those all hold. I want to get the side lengths. Of course, we know that's what makes a square nice. So let's get the length, and we can do every side, and we should see they're all the same. Good. And I'm going to measure the angles. I did those backwards. There we go. Control Z. Not that way. All right, but we can see the right angle. If I click any 2 of these. Got it. All right. Get back to the cursor. So no matter how I move or orient or dilate this shape, it's going to hold to all those properties we designed it with. And it stays a square. All right. Awesome. Well, that's going to wrap up our quadrilaterals, and this is going to wrap up our stuff with GeoGebra. Maybe we'll come back to it. There might be some extensions we might bring up, but for now, this should be a pretty good intro to all of the different tools we can use to build shapes. We've played with quite a good number of these, and some of the properties and ways you can use these as a powerful geometry teaching tool. All right, thanks for watching.